Good morning, everybody, and welcome to the AI Food and Nutrition track, the second of the Applied Machine Learning Days 2021. My name is Ugo Gentile. I'm one of the co-organizers of this track, together with Mireille Moser, Fabio Mainardi, Tom Eftimov, and Barbara Korosic. But before to start this exciting morning, I'm pleased to welcome Professor Marcel Salathé, that will take care of the general introduction of the day. Marcel, if you are ready, the floor is yours.
Thank you, and good morning, everyone. So I'm looking forward to this day. This is a very exciting day for me for many reasons. It is the second day, obviously, of the AMLD this year at the EPFL. I don't think it needs to be explained why we're doing this online. But I just would like to welcome everybody to this second track. The first one was earlier this year. And this time we're looking at the track that's called AI and Food and Nutrition, and then we'll have a third track later this month and multiple tracks down the road. Good. So one thing I wanted to announce before we get started is something we've already talked about last year, which is the idea that the Applied Machine Learning Days is an event that we originally created at EPFL, some faculty members at EPFL, but we've always felt that it could be a very useful event in many different communities. And I think that's now maybe this year became to be understood slightly better. Because everybody said, well, you can always do these things online, can you not? And yes, that's true, but I think we're now all learning or relearning the power of local and the power of actual meetings. Sometimes, unfortunately, it's not possible as it is today, and we'll make the best of it. But once that's passed, we're very much looking forward to go back to having physical events as well. And hopefully those will be all over the place. And one that we're very excited about that's coming up is here, as you can see, is AMLD Africa, which is actually organized by people coming out of the EPFL network who contacted us with this idea. And of course, we're extremely happy about that and super supportive. So this is going to happen in September 2021 in Tunis. The exact details you can find on the Applied Machine Learning Days homepage, where we list all the events that are coming up. And what you can see here, first of all, in terms of the dates, this is going to happen on the 2nd, 3rd, and 4th of September. But the calls are now open both for workshops as well as for presentations. And you can see here the deadline if you're interested to do a workshop or to speak at the first AMLD Africa. Here are your deadlines in May, so still some time, but nevertheless coming up soon. Very excited. Again, of course, the details will depend on the sanitary situation on the ground at that point. At the moment, it's planned as a hybrid event, with online elements and online attendance, but also with an on-the-ground event at the École Supérieure des Communications de Tunis in Tunisia. So stay tuned, and more information, of course, also then on the AMLD website. Now, I want to take this opportunity, of course, as always, to thank our partners that make all of this also possible. You can see them here. I'm particularly also excited to announce a new media partnership with What's On. More about that a little later this month, but this is something we're very excited about. Then I would say let's kick things off. So again, today is the AI and Food and Nutrition track. That's been a track that we had already for some time now, ever since we had tracks. And it's always been a track that's been extremely well received. And so we were super happy to see that track again at AMLD 2021. It's a fairly packed day, which is why I'll keep my comments very short here. Last time I counted, it had 23 talks. So I'll get out of the way ASAP. All of this is, of course, unfortunately online. I hope we will use all the networking tools available to make sure we can connect, and we keep connecting throughout the rest of the year. And so with that, I would directly like to hand over and welcome Patrick Barbey.
Thank you very much, Marcel. Thanks for having us. And we are really happy and proud to be supporting AMLD again this year. So Innovaud is the Innovation and Investment Support Agency of Canton de Vaud, Western Switzerland. And as you'll see in the slide, should you have any need setting up in the Canton de Vaud or supporting your innovation project, so don't hesitate to contact us. So today we are really happy to introduce a special session with 3 speakers, and we'll start with Christian Schwab, who's the director of EPFL Food and Nutrition Center, and also the president of the Swiss Food and Nutrition Valley. So I'm really happy to pass the mic to Christian. Thanks.
Thank you very much, Patrick, and good morning, everyone. It's a privilege to be here. So I will indeed open this first session about food and nutrition. The agri-food sector has been extremely slow at embracing the possibilities and promises of machine learning and artificial intelligence. There are many reasons for that. Probably a very conservative industry, very fragmented, a lot of state controls. And this is an industry that has focused for decades primarily on what I would call the chemistry of food, looking at innovation as a set of new ingredients, new product formulations and recipes, possibly new processing. But they have little looked beyond that from an innovation standpoint. There are signs that things are changing, and I will share with you some examples of that. But still, there are huge opportunities. And what is more, there's a huge urgency. I will spend a few minutes to share with you some of the challenges facing mankind when it comes to the food systems. I think the overall awareness from the public at large, from politicians, is raising very rapidly. But again, whereas a lot of attention has been put to energy, transport, and so forth, food starts to take front stage for very sad reasons, unfortunately. So concretely, what does that mean? Let me just organize my screen. Here you go. Let me share with you a little bit the background around food. Food is today consuming 37% of the emerged land. So the question of where will food be produced tomorrow is a relevant one. It is also responsible for a quarter of all the green gas emissions around the world. It is said now to be the single biggest contributor to climate change. It is consuming 70% of the fresh water drawn, knowing that water is already the #1 source of geopolitical tension around the world. And 1/3 of the food produced is coming from areas that are called water stressed, meaning the water supply is no longer guaranteed. Food is responsible for half of the 140 million tons of plastic waste being thrown into the seas. Half of it comes from food packaging. And the food systems at large are responsible for 70% of the loss of biodiversity. We know we're entering the 6th era of biodiversity loss. Well, 70% of it is coming from the food systems. 32%, that's a highly disturbing number. 32% of the food produced around the world is never consumed, is simply wasted. That speaks about the inefficiencies of the food systems. In an environment where 3.5 billion people are undernourished, out of which 800 million outright starving. The world hunger had decreased for decades and now is on the way up since 3 years and accelerating. At the other end of the scale, and we know this problem in our developed countries, there are 2 billion people overnourished and 500 million obese. There are more people dying from excess nutrition than from lack of nutrition nowadays around the world. And the most efficient techniques we have, such as intensive agriculture, are very often ecological disasters that need to be changed very rapidly. So a pretty gloomy picture, sorry to spoil your morning, but it just says that, and if we just apply some predictive models following the demographic curve and the improvement of well-being and conditions of living, we will need, I put a conditional, we will need to produce 60% more by 2050. In the period 2010-2060, that's 50 years, and we're already in 2021, we will produce more food than in the entire history of mankind. I pause here to let you reflect on the kind of challenge, the kind of shape we are facing here. But who says challenges, says opportunities? I can see now the graphic has been upset a little bit, sorry for that. But that situation offers huge opportunities. And that's really what I want to discuss today. From plant-based proteins, and we hear a lot about that, to precision farming, and we will give you some examples, alternatives to plastic, recycling, upcycling, microbiome, food waste reduction, alternative to antibiotics, you can see them, genetics, and security, authenticity, consumer trust. All sorts of digital applications can play a part in this solution. Some concrete examples of the potential of machine learning and artificial intelligence. You see what the area of so-called precision agriculture is offering already some very interesting signs. What you see here is a robot, fully autonomous with solar panels, GPS localization, and thanks to image recognition, machine learning, and robotics, this little robot can do what we call smart weeding and really applying herbicides at the very spot when they are needed. And by so doing, reducing by 95% the use of chemical entrants. A similar example is Gamaya. It's a spin-off from EPFL, where thanks to their hyperspectral imagery and analysis of the soil with different parameters and biomarkers, they can guide the farmers in all sorts of decisions, telling them when to apply pesticides, herbicides, when to water, when to harvest, and so forth. Again, preventing unnecessary losses at agricultural level. Another example of food waste reduction is a spin-off that we work with here at EPFL. It's a spin-off from AHL, as it happens, that works with the restaurants. In the back of house, they put this little device that is, again, using photonic capabilities, weight all the waste that are thrown into the bin, identifies them, and thanks to a feedback loop, helps the operators to reduce, to adjust their purchase of food and to adjust their recipe so as to minimize the waste. And as you can see here, by fully leverage the capabilities of this technology, you can reduce up to 40% food waste in a restaurant environment. The next example is the use of AI for de novo protein design by defining what functionalities you're looking for, and in nutrition, in precision nutrition in particular, really using food as a way to prevent disease and to drive healthy aging. You can think of tomorrow creating new ingredients with the functional properties that you're looking for. And again, to have these high throughput and predictive models, you need a lot of machine learning and artificial intelligence. Oops, I was too quick. Then another example, it's a startup in the US called Impact Vision that is already announcing that they will launch soon some device where, thanks to a mobile phone, you take a picture of your tray of avocado in the shop, you process the image, and thanks to, again, photonic technology, AI, and machine learning, the machine tells you back which avocado is ready to be collected and eaten within 2 days, 3 days, and 4 days. And by so doing, guiding consumers in their purchasing patterns and minimize food waste. Last example I have for you today is the idea of sensing of food using social media. So here really bioplanning techniques such as natural language processing, text mining, content and web network clustering, or deep learning, you can really follow conversations and try and assess what will be the acceptance by consumers of new food format, or what will be the aspiration for new food formats. And with the new generations, this is critical here. You can use that through text or, again, analyzing the images that people are posting on their website. So to conclude, my takeaway is for all the listeners today, to get a sense of the nature of urgency of the food-related challenges, but therefore opportunities as well for applications in machine learning and artificial intelligence. The fact that a broad range of application can be part of a solution tomorrow. And if, as you work on your technology, science, and applications, you can think of possible benefit to the food system, I really invite you to reach out to the Integrative Food and Nutrition Center here at EPFL. And our job will be to connect you either with the labs or with the industry players that could benefit from your thoughts and ideas. Thank you. This concludes my presentation, and I give the floor back to Patrick.
Thank you very much, Christian, for this interesting presentation. So now I'll pass the word to Carrol, who's the CEO and co-founder of Vivent. Carrol.
Thank you very much. I'm just waiting for some slides to come up. Can anyone help me with that? Perfect. So I'm delighted to be here today. The aim of my presentation is really to tell you how our business thinks about machine learning and how we use that to drive the machine learning build process. We're back at the start of the food value chain. We work with growers and with the people that supply products to growers. And we're delighted to kind of say that machine learning is really at the core of our business. And so it's lovely to be here today with you. I work with lots of biologists. They see a plant here, they see roots and shoots and a stem. But I think talking to people that are machine learning engineers, I really want you to think about biology, at least for a few minutes, as an information network. Surprisingly, crop health measuring is really an under-researched area. So I think it's an area where machine learning can make a huge impact very quickly. This plant, in fact, can sense a lot, in the air and in the soil, a lot of different things: heat, temperature, light, water gradients, chemical gradients, the presence of pests or pathogens. And it is continually sending information between the roots and the shoots of that plant so the plant can adapt to whatever conditions it's experiencing. And in this case, when you have such a series of complex signals that overlap in time and space, and you have an organism that's adapting its response to repeated stimuli, it really is, machine learning is a really fantastic tool to deploy if we want to try to interpret these signals kind of for good. So our machine learning engineers often start with a simple question. In this case, the question I'm going to talk through with you today is, how do the roots know what's going on in the leaves? So it's a really basic question, but I think good machine learning or impactful machine learning outcomes always start with quite a simple question like this. So I'd encourage you to think carefully about your question. Of course, to answer your question, you're going to need data. And here's an example of the kind of data we use day to day in our business. So we measure the electrical potential difference between 2 points on a plant. It's measured in millivolts. And if you happen to be a medical researcher looking at ECGs or EEGs, you'll say, hey, this looks pretty similar to my signal. Or if you maybe are working with speech processing, you'll also say, geez, if I zoom in on that, this looks a lot like a sound recording. So we have certainly drawn inspiration from both speech and image processing in our work. And again, I think when you're working with biology, it's really great to be able to look to some of the other sectors that are maybe more advanced and draw inspiration from them. So when we're thinking about our machine learning models, the other big question that we always answer at the start of the process is thinking about how our models will be deployed. In our case, we're deploying these models in real time, in field conditions. We use a small single board computer that can't draw very much power. So that really puts some bounds on the type of models we build and the type of analysis that we can do. And so we're always looking for ways of really condensing the amount of information into the smallest number of bits for our modeling. Here's an example of a way in which we do that. So I've taken my time-based signal, converted it to the frequency domain. So this is a spectrograph with frequency on the vertical axis and time on the horizontal axis. And different colors in here tell me about the power of the signal. So here I'm compressing a lot of information into a single image. And there we take these images as input for a CNN model. So again, think about the way your models will be deployed and think about how you might be able to compress information to give your models the best chance of working. So we're generating these kind of models, and I thought I would just quickly share with you some of the ways these models are creating value for our clients. Here's an example where I've used a model to detect an anomaly in a plant. And here I'm measuring the probability of stress in a plant over a long period. This is about a month of data. And you can see in the center of this graph that there's a period of high stress probability. For our user in this case, this is a really valuable piece of information because before we came along with these machine learning models, they actually had to pull the plant out of the soil and examine the roots. And that, of course, kills the plant. And so then it's the end of the experiment. Now using machine learning, they can continue these experiments and look for look at the plant development over a much longer period of time. I know machine learning is often used for anomaly detection, but I would just like to encourage you also to think about optimization, especially when you're looking at biology. So here's an example where we have used machine learning to generate the white band in the center of this curve. Again, I'm measuring my millivolt signal over time. And we noticed that the most successful growers have higher amplitudes in the diurnal rhythm of these signals. So we were able to create an optimal curve here, and now we can work with other growers, and say, hey, you can alter the temperature, the humidity, or the nutrigation in your system to try to stay within this optimal curve. So those are just some of the ways you can see that machine learning is really core to our business, and it's creating a lot of value for our clients. So I was delighted to share that with you today. We're always keen to talk to people about research collaboration or student projects. So we would be delighted to be in touch. I'm going to pass back to Patrick.
Thank you very much for this interesting presentation, Carrol. So let me introduce Matthias from the Buhler Group, who is the head of data science and also a quantum physicist. So the mic to you, Matthias.
Thank you very much, Patrick. So good morning, and thank you very much for having me today. So it's a pleasure to be here. So just waiting for my slides. Here we go. Perfect. So so you may wonder, so who is Buhler? And Buhler is actually a family-owned company from Eastern Switzerland, and we are a solution provider, so process solution provider for the food industry and for the advanced materials industries. And what you see on this slide is a typical day, and you would see that actually billions of people come into contact with products that have been manufactured on Buhler processing solutions. And just to give you a few numbers, so 65% of the world's wheat flour, 60% of the world's chocolate, and if I look at the very end, the beer, so 75% of the barley malt, the raw material, one of the raw materials of beer, they are actually produced on Buhler lines. Now, with these large market shares, of course, also comes responsibility, and for that reason, we at Buhler, we are really committed to driving innovation and, of course, also sustainability. Now, we want to look a little bit at how we're going to use data to enhance the quality and also the safety of food. And well, one thing, of course, that is important is, first of all, you want to know the risks. And what I'm going to show you here is a short video. And this is a service called Safe Food AI, which we developed a few years ago and also launched a few years ago. So you can also go there and test it if you like. And this simply collects information from the internet. And, there's a lot of information about any type of food safety incident available, recalls, alerts, warnings, all those things. And I just did a search for aflatoxin. So some of you may know aflatoxin. This is the most harmful mycotoxin, which is a toxin caused by mold fungi. And now if you want to know what are actually the most the products at the highest risk, you will actually see what turns up is a dried figs. And if you look at this, you would also see the, over the past 10, 12 years, some periodicity and, of course, seasonality. And this is, of course, a starting point to build a good foundation on data that then, of course, can also further be exploited. So this is now, some data you can find on the internet, but typically, since we are really, building machines, plants, like what you would see in the background here. So typical data we are looking at would look like this. So what you see here, that's another video. This actually comes from a service which is called Buhler Insights Replay. And what it is, it's a bit like your personal TV service. You can simply, use the replay function, go back in time and replay what has happened, on your manufacturing line. And this line, what you see here, this is actually an animal nutrition plant. So this produces some, let's say, 10,000 tons of animal feed per month. And what happens there is that from these orange bins, raw materials are dosed. They go through scales. These are these triangles here. And then they go through some additional mills, and then they end up in a mixer, and where they are mixed and then further pelletized. And now, of course, this is not only a video. How it works in the back end is that we can collect a lot of data, what you see here. And so we have about 10,000 signals that we collected with a resolution of less than a second. Now, what can you do with that data? And one important thing you can look at, for example, is how accurate is the dosing of all the raw materials. And if you think about it, often, we would dose hundreds of kgs, of kilograms of ingredients, at one time. And here you simply see the histograms. Again, this is, taking over a longer period, and you would immediately see where there are some issues, where the dosing accuracy is not as good as we want to have it, actually. Now, there are different, reasons for this, root causes that you can have. It could be linked to the raw material itself. It could be linked to mechanical issues. It could be linked to non-optimized process settings. But, anyways, we cannot fix it digitally. And for this reason, we have actually created a service or a concept called Plant Companion Services, which is a combination of on-site services, which is highly data-driven through, let's say, all this automated analysis that we do with our algorithms. This, of course, is only the starting point, and we're now moving further towards also, predicting, of course, such behavior. We're also moving towards prescriptive analytics, and of course, using more and more machine learning techniques as well. So there's much more to come here. So with this, I hope that was an interesting, still very short introduction to all the things we can do with data around food safety at Buhler. I don't want to finish before also, of course, saying a big thank you to our partners. So we have an office at the EPFL Innovation Park. So we work a lot in this ecosystem. We work with the Swiss Data Science Center, which is a joint venture of EPFL and ETH. And we also work a lot with a small startup company from this ecosystem, which is called Arcanite. With this, thanks again. And if you have any questions, of course, feel free to send me an email at the email address below.
Thank you. Thank you very much, Matthias. Thanks to all the speakers in this session. And now I'm passing back the mic to the AMLD day and wishing everybody a very interesting day of presentation. Thank you very much.
Thank you, Professor Salathé, for your introduction, and thank you to Innovaud and all the speakers for their contribution. And now we will have a 5 minutes break, and then after, Tom will hand over the floor to start our track program and introduce the first speaker. Stay tuned.